In this module, we want to talk about modeling and simulation sort of as a profession and what it means to be a modeling and simulationist as opposed to other things, what makes us unique, all those sorts of things. Um, and so our topics will include things like we'll talk a little bit about is modeling and simulation a discipline? So, like for example, at the Naval Postgraduate School, the modeling and simulation is its own thing. It's not embedded in anywhere. So it stands alone, and it actually was designed as a hybrid, part computer science, part operations research. And maybe ask the question: is that valid? Is M&S a discipline? What does it even mean to be a discipline? And we'll talk a little bit about what modeling and simulation professionals actually do. Um, and how do we fit this into the bigger picture of training, education, and operations? And lastly, what do others expect of us as modeling and simulation professionals? So let's start with is modeling and simulation a discipline? So if you'll let me go on a short academic tangent, just bear with me for a moment. So first of all, like what is a discipline? If you've got a university, you have a computer science department, you have an electrical engineering department, you have a philosophy department. Those are disciplines. There's some sort of a set of rules that define what are the topics that belong in one of those departments versus another. Um, so a discipline traditionally is knowledge or wisdom associated with an academic field of study, and usually a discipline will have a core set of knowledge and skills, a certain type of expertise that you don't find other places, a unique set of problems and challenges that you won't find in other places, often specific studies and lines of inquiry that you won't find in other places. Approaches and methodologies. You go to a business school, for example, there are certain methodologies that you find in business schools that you don't find in other departments. They don't use those. And certain research areas that would be unique to that area. So let's now do the sort of pull the thread on this and talk about, well, does M&S meet the criterion? Is M&S a discipline? Let's follow argument number one. We'll say that M&S is not a discipline. And we'll just say that it's a synthesis of computer science, mathematics, operations research, social science, psychology, all these other disciplines. Many of you are from the medical and healthcare disciplines. Throw those into the mix as well. Um, M&S is an artifact. It's just an artifact, or it's a tool of those disciplines, just like anything else. Be like saying that we use mathematics in engineering. Is engineering not allowed to use mathematics because we have a math department? That would be hard to do any engineering. Um, they have these disciplines for the purpose of study and exploration. And we could say that all members of the M&S community are really actually from one of these other disciplines, and they just happen to be applying their skills to this artifact that we call modeling and simulation. And the example that I like on this is that you have Galileo, who from astronomy, studied optics. I mean, he actually invented optics, not because he was interested in optics per se, but he was interested in astronomy. And so his field of study was astronomy, not optics. But he needed optics, and he developed many innovations in optics for the purpose of studying his primary interest, which was astronomy. Okay, so now let's flip this around and look at argument number two, that M&S is in fact a new discipline, and that it does have unique knowledge, tools, methods, expertise, and challenges that are not found in other disciplines. What are some of those? Well, you could make an argument for agent methodologies. You will find those most definitely in computer science and other areas, but some of the unique ways we use agents are in fact unique to modeling and simulation. Most definitely interoperability. The way we have simulations talking to other simulations is only attributable to us. Um, Validation, verification, and accreditation, unique to modeling and simulation. Very unique to modeling and simulation. Some aspects of human interaction are unique to modeling and simulation as it pertains to training, not so much human factors. Um, And M&S is an artifact or a tool for other disciplines for the purposes of study and exploration, but there is an argument that the artifact itself has reached a level of interest as to be considered a discipline of its own. So going back to our example of Galileo, yeah, Galileo studied optics to help him study astronomy, and eventually somebody looked at the optics and said, you know, this is really interesting all by itself, whether you're using it for astronomy or not. So the artifact itself became a new discipline, and we now have a new discipline called optics, and there are departments of optics at certain universities. Not everyone. Often it's embedded in other departments, but optics is widely regarded as a discipline of its own. So now both of these are actually well accepted academic disciplines. So you can kind of see which way I'm leaning on this, but I kind of leave it for everybody else to kind of decide. I put this together years ago. We were actually defending the position of modeling and simulation at the Naval Postgraduate School as its own thing. And the way I've always tried to describe this to people is what you see on the right is literally every department on our campus, and on the left is just modeling and simulation. And the way I describe this is that you will absolutely find modeling and simulation everywhere on our campus. There's a funny story about the founder of the MOVES Institute called a meeting many, many years ago and said to the entire campus, hey, DoD is getting really interested in modeling and simulation. Let's have a meeting. Everybody who's interested in modeling and simulation, come to this meeting and we'll kind of see what we want to do. And the way the story goes is basically the whole campus turned out because modeling and simulation is everywhere. Everybody does it. And so kind of realized we're going to have to be a little more specific than that. And so what MOVES actually evolved into was modeling and simulation professionals whose focus is the artifact itself of modeling and simulation, not merely the application of modeling and simulation to solve a meteorological problem or a physics problem or a system engineering or acquisition problem, but rather the study of the tools themselves for acquisition, analysis, testing, et cetera, et cetera. So that's kind of how I've described it as how what we are as modeling and simulation professionals is different than everybody else who is using modeling and simulation, but only as a tool. Now, continuing on, the role of modeling and simulation has in some ways actually influenced the scientific method itself. So if you remember the way the scientific method works, you come up with a theory. You have a theory that light is not it's not a particle and it's not a wave. It's a combination of a particle and a wave. That's your theory. You craft hypotheses that are related. What does that theory imply? There are hypotheses, provable statements statements that are provably true or false. Then you come up with experimentation that will test out your hypothesis. We'll know how this works, right? And then, based on the results of your hypothesis, you've got a feedback loop, both to your theory and your hypothesis, to try and fine-tune them as you're seeking truth on what actually is really going on. And what we found now with the role of simulation is that there are so many things that doing the actual experimentation in the real world is either impractical, too expensive, too dangerous, where you still have your theory and you still have your hypothesis, but now you simulate and you do the experimentation on the simulation itself, which then goes back into the theory and the hypothesis, right? So a simulation has now become a fundamental part of the scientific method. And the interesting thing here that I want to point out is that this notion of validation is key in your simulation because you need to understand what you did simulate and what you didn't simulate so that when your experiment produces results, you know if any of those results are artifacts of the limitations of your simulation and therefore could be giving you misleading guidance on your theory and your hypothesis. So this is just an interesting way that science itself has been impacted by modeling and simulation. Now I want to go on to a little bit of a sidebar that we didn't used to cover, but I think it's important on what what's the rest of the Department of Defense in particular doing in modeling and simulation? So I'll call this conventional DoD modeling and simulation. If you'd go to a DoD modeling and simulation meeting, this is what they're going to be talking about. They basically have three main focus areas: training, analysis, and acquisition. We'll see in a minute that it's actually a little broader than that, but those are really the fundamental three. Um, and then within training, which is the big one that we're focused on too, we have this piece we call LVC, which stands for Live Virtual Constructive. I'll talk about that in a minute and tell you what that is. We also talk about individual versus collective training. And we do part task versus whole training as well. There's a lot of staff training that goes on inside of DoD. It's sometimes useful to see this notional governance structure. We used to see this a lot more often, and I see it less now than I used to, but I still think it's useful as a way of describing how modeling and simulation permeates all of Department of Defense. So what you have, this has been referred to as the surfboard picture. On the vertical slices are the different focus areas or application areas to which modeling and simulation can be applied: training, analysis, acquisition, and now here's these other ones that pop in, and the list can change. There's test and evaluation, experimentation, intelligence, planning. There's all sorts of different pieces. There could be cyber. Depends on how you want to split up the topical domain. You get all these different focus areas. Now, the way DoD works is that each of these is actually managed by some type of a command, right? So inside of the Navy, for example, you would have training would be possibly the Naval Education and Training Command. And there's some others that would play a role in who's responsible for training in the Navy. Training, not M&S training, simply training. They have an interest in M&S as it applies to training, and they're the ones who should be telling us what are the requirements, what are their needs. Same thing is true in analysis. Same thing is true in acquisition. You have all of these different pie slices have a center of mass of folks who are responsible for that particular domain, and they are critical in telling us what their needs are from M&S. How can M&S help them to do their jobs better? Then you end up with these green horizontals, which are called the crosscutters, where you have M&S tools that actually can go across the different domains, different data sets, different services, standards, protocols. These are all things that are things that apply across all the different domains. And this has been traditionally the role of the coordination or management offices. There used to be like a defense modeling and simulation office. We have I'd like to ask if you think the Defense Medical Modeling and Simulation Office should maybe be doing this for DoD medical and healthcare simulation across the board, right? Should they be standardizing on tools, data, services, and standards as they apply to everybody, so that no matter where you are in DoD, if you're using M&S, you can lean on them for at least some basic infrastructure that you can then not have to do everything yourself. Because what you end up with if you don't do this is everybody's doing their own thing, and it actually makes interoperability, which we're going to talk about in a minute, all the harder. Okay, so I just wanted to give you that picture of how DoD notionally manages itself. Now we get back to this live virtual constructive notion, and this is extremely hot right now. You really can't talk about modeling and simulation in mainstream defense M&S without talking about LVC. And the dream here is that we are going to have, you can imagine live ranges like NTC, 29 Palms, etc., where you actually have live entities that are doing live exercises like they normally do, but they're now instrumented in some way. They need to be instrumented because at the same time, we have people in virtual simulators. And at the same time, we have what's called constructive simulators, which is sort of like a battle management sort of a tool that can maybe handle like your OPT4 in a particular exercise, can handle different entities that you don't want. You want to be driven by algorithms, not necessarily by people. And the dream here is that no matter who you are in this environment, in this large training exercise, you can't tell who anybody else is. So if you're live, you're out in the field doing something, um, you're getting stimuli from, let's say, air assets. They're actually in virtual simulators at a different location. And you get an OPT4 that you're actually firing at that's being driven by a constructive simulation that's producing that OPT4 that you're being asked to engage. So that's kind of the dream of what LVC is all about. Here's sort of a high-level picture of how this might work. And what you're seeing here is look at all the different locations where people are participating, and you'll notice you've got ships at sea, you've got air assets in the air, um, and everybody's they're all digitized, so we know what everybody's doing, and everybody's being pulled together. You actually have people in virtual simulators in different locations. You see you've different trainers. You've got virtual simulators in the upper left. You also have constructive simulation that's sort of doing your battle management, and you can imagine these large scale high fidelity types of simulations where it's a complete sort of a mashup of all these different types of entities all operating together at the same time. Now you can imagine the M&S issues that are involved in this. The networking issues of how everybody is going to be communicating with each other, how everybody can understand what everybody else is doing, how everybody interoperates with everybody else. How do you deal with time lag? Everybody's not co-located, so you got to make sure that everything is happening at the same time. This is sort of the current grand challenge of defense modeling and simulation right now, and what we're actually doing. Now, the reason I wanted to introduce this to you is, where do you see medical in this? I don't see him in here at all. And I can tell you that to a large degree, when you talk to defense modeling and simulation, you're not even on their roadmap. They're not thinking about you at all. And yet, you play a very critical role in everything that's going on here. So how does medical healthcare modeling and simulation play a role in these large LVC types of environments where we want to train along with everybody else, and we want to get a training benefit. We also provide a training benefit to others. It's just sort of something I want to put in the backs of your minds of up until now, medical M&S has almost sort of operated as its own thing. It's ahead of conventional modeling and simulation in some areas and lagging way behind in others. You start to see some of the things that are like going on at USU, for example, that are really heading in the right direction in terms of the sorts of large-scale simulations that the rest of the DoD world will nod their heads and go, yeah, I get it. That's exactly what the kind of thing that we're doing. So I think that there's a pathway for bringing all these things together, but this is maybe something we'll talk about later in the quarter of how do we sort of get into the conversation with the rest of DoD VA modeling and simulation, so that we're all benefiting each other, and we're all improving each other's products. All right. So lastly, I want to talk about what do we actually do as modeling and simulationists. Well, we do all these things, right? We build models and simulations, we train, we do exercise support, operations analysis, we do trade-off analysis, we do procurement, system development, VV&A. These are all things that we do as modeling and simulation people. So it's a really, really wide set of things, of skills that M&S people have to be able to do. How does this fit into training and education? Well, from what we've discussed so far, Which of these sorts of things happen at your organization? I mean, are you building models, simulation software? Maybe not. You might actually be just procuring them and using them. Do you ever specify requirements for acquisition? Do you ever say, hey, this is what we need? Somebody needs to purchase this for us? Do you test and validate products for potential solutions? Do you construct learning plans for trainees and students that have to meet particular performance goals? Do you run exercises or training events for others? Are you responsible for being the person who knows where all this is going so that we don't fall behind? That is keeping ahead of the curve, right? So what do others expect of us as M&S professionals? So one thing is they're going to say, maybe you didn't think you were technical before you did the certificate, but to some degree you kind of are now, right? So you're technical, so you kind of know, you've done stuff with computers and operating systems and networks, and you know a little bit about security and devices and displays. You've done that kind of stuff. You're also into training, so you know about things like training schedules, you know about how people learn, you know about how to craft assessments to see how much people have learned, you know things about skill decay, all those sorts of things. You know about issues like fidelity and simulators, like what do you have to represent, what don't you have to represent. You're also military or VA in this case, so you know a lot about methods and procedures, best practices, standard operating procedures, variations on standard operating procedures. You know about how the government works, in other words, right? So you know that. And you're government professionals, so you know about procurement practices, you know about things like federal acquisition requirements or regulations for financial rules. You know about all that stuff too. And in reality, you're all of those things. So you're going to be knowing about things like writing proposals and strategic planning, how to secure resources for your organization and your sim center, and hopefully a little bit about inventing the future. And that's really where we want to go with our class this quarter. All right. So hopefully that's been useful to you. To kind of just give you a little bit of a roadmap, I wanted to hopefully talk a little bit about the bigger picture of modeling and simulation and what it is, what the defense industry thinks modeling and simulation is, and how we all fit into that.